Always trust but always verify is what I say, and here to do that I've run show IP OSPF interface serial 0. And the show IP OSPF interface command is one I come back to regularly, as you've already seen and will continue to see, because you get so much great information from it. And when you're walking into a network that you've never touched before and all of a sudden you're troubleshooting it and or configuring it, hopefully your configurations aren't causing the troubleshooting. They won't if you get the information from this command, because you see the IP address of the interface, the area it's in, the local process ID, the router ID, and notice that's 1111, even though again we have not put the loopbacks into OSPF yet. So we'll talk about that. Your network type of non-broadcast, there's the interface cost for OSPF 64. It's telling you that this is the designated router for the segment, even tells you what the local priority is. Then it's going to tell you who the DR is, the router ID and the interface address for the designated router. There is no backup designated router on this network, which is what we want, and it shows the intervals, and it also down here shows you how many adjacent neighbors you have and who they are. So that's fantastic stuff. One more thing I wanted to show you down on router 2, because I'm sure you're thinking, okay, if a physical serial interface defaults to non-broadcast and the point-to-point interface over on router 3 defaulted to a point-to-point network, what does a multi-point sub-interface default to? I bet you already know, but we're going to take a look here. And you can see non-broadcast. That's what it defaulted to. So that's why the adjacency with router 2 came up, because those hello and dead timers matched up, where 1 and 3, of course, as we saw, did not. And you can see here, here's the information on that sub-interface, and it says, you know, I'm a DR other, and that's because I'm neither the DR nor the BDR. Now we're going to get those loopbacks into our network, and then we'll take a look at a routing table, because we really haven't done that yet. And let me ask you something. I'm going to use a wildcard mask, of course, here. Now on router 2, my address on the loopback is 2222. If I want that address and only that address to be enabled with OSPF with this network statement, what what wildcard mask should I use? It's kind of like a host wildcard mask. I should use all zeros because all 32 bits matter, and in a wildcard mask all of my bits, my iCare bits, are 0. And then I'm just going to set it to area 2, and that's it. And that is it. Actually, we'll go back to router 1 now, because now we'll have some OSPF routes. Before, every router, the only routes we had were the frame network, 172.12.123.0, and we had, well, that was it at that point. Well, that was a connected route for all of these guys. So they knew about it already. That would not have shown up as an OSPF route. But now when I run show IP route OSPF, I am going to see the other loopbacks. Now I'm not going to see router 1's loopback when I run show IP route OSPF on router 1, because OSPF didn't discover it. We already knew about it. It was a connected route. A couple of things I want to show you here as we look at an OSPF routing table. You've got an O and an IA there. Now we can guess, of course, the O is for OSPF, and we know that's correct. But what about that IA? The only drawback with show IP route OSPF or show IP route static, whichever one you want to run, is that, and of course, let me show you this real quick. Now I interrupted myself there. So you can run it for any of these. You could do it for OSPF, you can do it for static, you can do it for EIGRP, and in the future when you're using some of these others, you can filter them in other ways. But when you run show IP route, you get this routing table, and especially when you're first getting used to it, it's nice to have access to that routing table. And that's the only drawback when you use the filters, is that you don't get that code. So here we've got OIA. Well, the O, of course, is for OSPF, but what about this IA? That's an OSPF inter-area route, which means that destination is in an area that the local router does not have an interface in, so it is in another area. where anything, if we had put them in area 0, they would still appear here in the table, but they would not have that IA next to them. Going from left to right here, let's check out these brackets. We have a 110 and then a 65. The 110 is the administrative distance of OSPF. I mentioned AD a couple times throughout the course, but in case you haven't heard that part yet, or you're a little foggy on it, the AD is simply a measurement of a route source's believability, because this router could be getting the exact same route from 2 different protocols. And it's got to say, okay, which one of these should I put in the table? Now, what should I do? And there has to be some measurement of believability. And that AD runs from 0 through 255. 255 is considered completely unreliable. So obviously, the lower, the better. The further we are away from 255, the better off we are. OSPF administrative distance is 110, and that is true for all of these route types up here, the ones you learn about now and the ones you learn about later. You can change it, but it's rare you're going to have to do that. The reason I even mentioned that all the OSPF routes have an AD of 110 is that when you get to EIGRP, I'm going to show you that one kind of EIGRP route has one AD and another kind has another AD. But with OSPF, we don't have to be concerned about it. You're also going to see what the next hop IP address is and how long it's been in the table. That can be helpful in the stuff. And here's serial 0. That's going to be your exit interface there at the very end of it. So we can also run, to get a little more extra information, show IP protocols. And this is going to show your gateways. There's the distance. It doesn't say admin distance, so I want to make sure that you know what's going on there. It's going to show you the local networks. Number of areas in this router is 2. 2 normal, 0 stub, 0 NSSA. Those are more CCNP topics, but I'm going to talk to you about stub routers a little bit in this course. And there's the magic phrase, it is an area border router. And we talked about that router type earlier. That's a router with an interface in area 0 and another interface, at least one, in another area. So far so good. We've got our loopbacks in there, and we've got connectivity to them. That's not going to be a problem. Never hurts to ping them, because just because you see them in a routing table doesn't necessarily mean you can get to them. But with ping those, there's no problem there. What we'll do now is add the Ethernet segment to our network. We're going to put that in area 23. I expect that route will already be here. That did not take long at all. Notice now, though, we have 2 entries for the route. The AD for them is both the same, of course. That's 110. But notice the cost is exactly the same, 74. We're going to talk about how that cost is arrived at, and we're going to work with it in a couple of labs later. But that's why we're seeing both the routes put in the table. They have the exact same metric. So OSPF is going to do that load balancing and say, okay, if it's exactly the same to get to 172.23.23.0 through both 123.2 and 123.3, then we'll split the workload. OSPF is going to do that for us. So now we've got our Ethernet segment in, and we've got our loopbacks in. So I'm going to stop this lab for right now. When we come back, we'll hit it a little bit more and hit another important OSPF topic. See you on the next vid.